First of all, I'd like to welcome everybody to the basically the second Python tutorial. So let's see here. So basically, we had the okay. So the instructors are I'm Andy Somogye. I'm a research scientist here. I did last week's talk, and I also helped out with Herbert's talk. Herbert's class last week. Had a chance to interact with some of you there. Okay, let me move this thing over. Okay, yeah, so also helping out, or we have Javier and Giuliano, and I'm sorry I forgot to list them here, but we have also Jim Sluka helping out here. So we're going to go ahead, and so today I was going to sort of do it a little bit more unstructured than last time, in that the topics I have really scheduled for today are really dictionaries, classes, and a little bit of file I/O. However, we did have some people who weren't here last week. So looks like what I can do is, looks like I'm looking at the poll, just about everybody here was here last week, and we have a couple people who weren't. So what I was going to do is go ahead and why don't we do another poll? So what I was going to do is go ahead and start with the new topics of dictionaries and classes, and then after I finish those up, we can sort of make this as one big little help session, breakout room session. And then I will stay on as long as anybody has questions. I'm more than happy to work through examples or any other questions that you guys have. So let's go ahead and get started here. So, oops. Let me open up the right slide. Let me get to the right slide. So I think that worked pretty well the last time, where I had one window open here, and then I had another window on the side of it where I actually had a tellurium window. So let me go ahead and run. So yeah, so I'm going to be working through using using the Tellurium notebook on NanoHub. So let me go ahead and start this guy here. And it does take a minute for this to start. Just a second. Okay. So one thing that is a little bit tricky with the Tellurium is that you do have to make a file new notebook. in order to have something that is editable. That is just a little bug on NanoHub, and we are working on getting a workaround to it. Okay. So what we're going to talk about here today is a little bit on, actually, let me go ahead and do the dictionaries one first. Oops. Okay. So yeah, last time we had, last time on the first class we had an introduction to Python where we went over basic expressions, variables. We did a, why does this keep showing up? We did a bit on branching, on iteration. We went over the standard sequence types such as lists, strings. We also did a bit on NumPy arrays and matrices. And for those of you who attended, so I'm going to be using the NanoHub Tellurium app. That's what I'm going to be demonstrating on today. But if you're using another Python environment, you're perfectly free to use other ones. But bear in mind that I will be demonstrating it with NanoHub, the NanoHub Tellurium app. Okay, and so for those of you who took Herbert's course last week, we obviously did a lot of NumPy array manipulation in terms of stacking and concatenating arrays and doing various other array operations. And we also did a bit with functions. So what we're going to start off with today are dictionaries. So what dictionaries are is they're conceptually very, very similar to a list in that they're what's called a collection class in Python, and they allow us to map an identifier to an object. So we will be using when we start working through CompuCell models, dictionaries are very, very heavily used CompuCells to attach attributes to cells, to attach attributes to other objects, to access attributes of other objects, and as a general way of storing and accessing different bits of information. So dictionaries are really, really useful. Okay. So one of the examples I normally do is, let's just say that you are tasked, you're given an assignment of assigning student names and assigning them various attributes, such as, say, their grade in the class, or what course they took, or various other bits of data that you want to associate with a student name. So one way of this, if we did not have dictionaries, is effectively to write your own organizing or mapping routine here. So one way of doing this, and I'm just using this as an example, is we would create a separate list for each item. So the important thing is each list must have the same length, and then how we map individual items is because we create a list, each one has the same length, we essentially say that the index of that list is the commonality between all these different items here. So we have Anna, who's index 0 in the names list. Her attributes, her grade would also be that B, which is index 0 in the grade list, and the course the course would be a 2, which is an index in that course list. So let's just say we wanted to pull out, let's just say we want to figure out what grade she got, okay? Well, we would write a little function here called getGrade, where you give that function the name of the student and the other lists that you stored those different attributes in. The first thing you do is you would find the index in the student names list. So you would call one built-in Python method of index, which where you give it a object, it gives you back its index in that list. And then you would pull out the grade from the grade list, you would pull out the course from the course list, and then you'd return that as a tuple. So this concept of mapping data items to identifiers is extremely common. This is actually one of the more common things that we do in modeling. So using this really low-level approach is messy. There are a lot of things you have to keep track of. You have to keep track of many lists. You have to spend a lot of time searching for indexes, and you have to remember to just, you have a whole bunch of balls up in the air and you're always trying to juggle them. So it's not a good approach doing it this way. But luckily, Python and actually most other modern languages, they recognize that this is a very common motif of mapping, of associating data items with different kinds of indices. So Python gives you this data structure or class called a dictionary. So what it does is, in a dictionary is very much like a standard list, where when we look at a list associates a number, or actually specifically an integer identifier, with an object stored in that list. A dictionary is almost exactly the same thing, but it doesn't give you that restriction of using an integer identifier. Rather, in a dictionary, you can use any identifier to associate a data item with that identifier. So in a dictionary, we can create a container that directly associates names with various other attributes. And that is exactly why it's what's called an associative container. And you may hear computer people using that term, associative container, and this is exactly what it is. So the syntax for creating a dictionary is really simple. So an empty dictionary is, we create an empty dictionary simply by doing my underscore equals square brackets, curly braces. So that creates, if we go ahead and print out this guy, we see that it's an empty dictionary. So now if we want to create a dictionary that is populated with stuff, syntax is also, as we'd expect, pretty similar. We could do something like grades, the name of the object equals curly brace. Now we give it various keys. Actually, we give it, oops, why am I moving? And that's the, what's called a key, which is the thing that you're using to look things up, and then the data is what we associate with it. The comma, the students did really well in this class, didn't they? Okay. So we see that it's name, the colon, thing, name, colon, thing, name, colon, thing, comma. And then we evaluate this, and then we give that back. So looking things up. So we've made, lists before. We did my underscore list equals actually, I want to do that. Okay, so we did that. Actually, I got a question for you guys. A little bit of a side note. This is, you'll notice when I did my list definition here, I gave it strings. Let me just make it more clear, 1/6. And then I print that out. Huh. So what happened here? Why did I, when I typed this definition, why did I type 1/6 here and it showed up there? Who would like to guess at why that happened? Do we see any answers in the chat here? 1/6, it's close. Actually, let me do another one. How about 1? What's going on there? Why is it that I type in this expression and I have these funny little things that, so basically what I'm trying to do here is I'm trying to store these values in a list. But so as Ajay very correctly points out, what's going on here is when I write this expression, okay, I do the name and I'm signing it these things. And then inside of my list definition, we have hello. This is obviously a data object. We have A, that's obviously a data, 1, 3. But now, hey, we get to this thing. This is an expression. This is an expression. So what goes on is how Python works, and in fact, most other languages, how they work is when you have the right-hand side here, we see that the right-hand side is what's called an expression. And it has little nested expressions in there. So what actually happens is when I type in this expression. The basically interpreter goes and looks at it and looks at all these sub-items here. And if any of these sub-items are an expression, it goes ahead and evaluates that. So that is just, it's just something to be aware of, that may be a technique that you may find useful, but don't, it's just, when you encounter this, when you can actually have arithmetic and various other expressions in here, and all of will evaluate it first, and then the results of these expressions will get stored in that list. Okay. So now, going back to my little great example. No, a list can have, a list is what's called a heterogeneous container, in that we can store different kinds of objects in a list. So in a Python list, you can mix numbers, strings, objects, whatnot. But yeah, NumPy arrays, if I do a NumPy arrays have to be homogeneous. So we can do A equal, actually, import NumPy N equals array minor unknown syntax. Okay, so one other thing that you might notice that happened here is if you look at how I did that array definition, the first number is a float, and then the remaining numbers are integers. So because NumPy arrays have to be homogeneous, what NumPy does is it looks at every object that you're wanting to store in that list, and then it figures out what is the most general one in there. Which kind can I represent all the other ones in with a minimal loss of information? So here it determined that 1.2, the only way I can store 1.2 is as a float, but then the other ones are integers. So it says, hey, I can convert integers to floats and generally not lose information. There's it's a bit of an advanced topic. If anybody has any questions, I can go over why I have to preface that with generally after the class. So if anybody's interested in that, just talk to me after the class. But for the most part, you can generally convert integers to floats and not lose any information. So, but now we have A. So we have A is an array of floats, and then if we try and do A2 equals stuff, it will give you an error saying, hey, I have an array of floats. You can't store anything else in there, but we can do my list. We could type right. We have all sorts of stuff in there. So going back to my dictionary. So we have grade. So accessing individual objects in there is literally the exact same syntax as using a list. So I can do grade what? Okay. I can do grade, and you saw I tried to look it up with some other, like I say, I tried to do index. Yeah. If I store these pairs in a dictionary, I have to use the name of the thing pull the value out. Are arrays in Python all dynamic? No. Standard lists in Python, such as mylist, those are dynamic. We can extend those. You can store any other values in there. However, NumPy arrays, NumPy arrays are fixed, and we cannot extend or lengthen NumPy arrays once we've created them. We can, however, create another array that is bigger than that one, that contains more, and then make a copy of it. We do that with a slicing one. So lists are dynamic. NumPy arrays are their static size and their static kind. Okay. So adding an entry. So we can set values such as grade. I guess I actually did really well. Equals. And that, as we would expect, that set that value. Well, let's just say we want to add a new person here. So we could do grade, index, Bob. No, Bob's not in here. Let's put Bob in here. He was a naughty boy. So that simply added a new element to this dictionary. What if we tried to do that with lists? So we had my underscore list. Okay, so we did len. That's 6. So we can, let's see what happens when we add a new element in here. 7 equals, so lists, you can append to lists, but if you try and add a new element in a list using an index that's not already in there, it will give you an assignment error. So in this sense, dictionaries are much more dynamic than lists, in that we can arbitrarily add as many objects as we want to. So adding items to a dictionary, it's simply calling the square brackets and setting values. But lists, you have to append it. So if we want to append a new item to my list, append 5. And now that added it. Okay. So how do we tell if a key is in a dictionary? Well, we use the in operator. We use the in operator. So we can do in grades. Yeah. Oops, typo. John in grades. So in is a very useful keyword in NumPy, in Python. We use the in operator to check if items are in a list. So we can do 5 in yeah, that's true. So in. very powerful built-in operator. Okay. And then going back, which one is true? So we had grade, we can do true. Another thing that I will have to give you a little, be aware. What if I did John? That's false. Capitalization matters. Capital John is different than lowercase John. So you do have to be aware that keys in a dictionary are case sensitive. Okay. So similarly, we can use the del function to delete values in a dictionary. We can do del grade okay, and then John's gone. Okay, so the syntax for that is del. You have to call del as a function and then give it a collection for the thing that you're pulling out of it. It's just the way it is. In Python, some things are functions, some things are operators. So, and it's really you just have to whip out a little Python cheat sheet that we provided or any other one and look it up whether something is an operator or a function. It's just something to be aware of. Okay. So can grab we can grab all of the keys and all of the values here. Okay. So we can do grade dot keys. Okay. So we can see grade dot keys. We're calling a method on our dictionary. And this returns essentially a list. So you could do something like for k in grade dot keys. Okay. And that iterates over all of the objects in this list that's returned and prints them out or does whatever to them. Similarly, we have grade dot values. And that also returns this little thing called I know it says dict values, but really it's just a list. You have the actual values in there. So dictionary, we have keys and values. We can access each of them as a list. Now, one other little thing that you have to be aware of is when you grab the keys or the values out of a dictionary, there is no guaranteed order. When we grab the keys, they can be in any order that the dictionary decides to put them in. It doesn't matter. The order in which you put them in is irrelevant. It's just, it's going to store them internally however it sees fit. So no guaranteed order in the sequence that the keys or values are returned to you. Okay. So keys and values. So the value can be any type. Just like a list, we can store numbers, strings, whatever as values. Keys, we have a little bit of a restriction on what we can use as keys. So the main thing is keys have to be unique and they have to be immutable. They have to be this other thing called hashable. You don't have to be aware of what it is. It's just a little thing that it puts on there. But anyway, so we can adjust our grade like this. Okay. We can actually, if we wanted to, we can use a number as an index. So we can do grade 0 equals stuff. Okay. So look here. Now our dictionary went from having just strings as keys, and now we have the 0 as a key. So you can actually do grade and pull out. So you can use numbers as keys. You can use floats as keys. You generally cannot use arbitrary objects as keys. So you do have a restriction in that what you can use as keys are numbers, numbers, integers, floats, strings, tuples of these primitive types or rules. So you have to use these as keys. If you want to do some really advanced stuff, you can create custom objects and use those as keys, but you will never ever be doing that in Pup. So okay. So list versus dictionary. List is an ordered sequence of elements. Dictionary is unordered. So if you need to keep track of the order, you should use a list. If the order doesn't matter to you, Dix is a totally usable option. List looks up elements by an integer index. Dictionary looks up elements by a key. Okay. Indices have an order in a list. No order is guaranteed in a dictionary. And in a list, your index has to be an integer. But in a dictionary, your index or key can be any immutable type. Okay. So let's do a little exercise here. We can do so something we might want to do is count how often certain words show up in song lyrics. Okay, so we could do something like define a little function here called lyrics to frequencies. We could make a dictionary, empty dictionary, and then we're given a list of words, lyrics, and let's see what we're doing here. So we can do 4 word in lyrics. So we're going over every word in our lyrics, okay? We're using the in keyword here. If word is in our dictionary, then we grab that existing object and we increment 1 to it. Otherwise, we insert that word into our dictionary and then we return that one. So literally what we're doing here is we are creating a histogram of how often we encounter something. Okay. So why don't, let's go ahead and actually have you guys do this example. So we can just go to Google, and we can just find some random text from somewhere. And let's go ahead and do this. So we can go to Google. So we can copy this and paste it into our notebook. We can do text equals, and I'm pasting this. Enter, so we have okay. So I just did some random text. You can grab any text you want. Plain text. Random text. Okay. No idea what's in there, but okay. So that's right now, that's a single string. We want to split that into words. Who hazards a guess as to how I can split a single big text string into words in Python? I would do words equals. Who wants to guess? Anybody? Answers? Okay, we can try something. Split, yes, split. So we can do text dot split. Look at that. Isn't that nice? We can do words equals, actually, words. Okay. So what this does is it really nicely goes through the entire text string and then splits it up into words. Okay. Then I can write my little function here. We can just, it would be really great if you guys followed, but we can do def. Well, this is actually very general. Things. We'll just call it things. Okay. So inside of here, we can do, I'll just do a histogram because that's exactly what we're doing here. For thing in things, if thing in list, thing, incrementing that by 1. Okay. Oh, equals 1. Great. So I wrote a quick little frequency function. Then I can do frequency words. Why does this keep showing up? Okay. So that gave me a dictionary back. Let me bring this up a little bit here. That gave me a dictionary back of how many times I encountered that thing. Okay, so style met, ooh, and as we would expect, and shows up pretty frequently. Various other words. And you see that there's no order in here. The neat thing is because this is actually really, really general, we can go ahead and use our frequency function for other things. So, and this is actually likely something that you will be doing, certainly in bioinformatics. You will very likely be doing something along this nature in CompuCell of seeing how, making histograms of how often you encounter things. So let's just make a list. So uh, numbers equals okay. And then we can do free. Ah, look at that. So it makes us a dictionary where, yeah, one, we've encountered one 4 times, 0, twice, -1, 3, 34, so forth. Okay. So split dictionaries. Okay. So using the dictionary, let's do another little thing of what are the most common ones in there. Okay. So what we can do here is we can do the most common, grab the values out of there. We can use max. Okay. What does max do? Max returns the largest value in values. Then we can make an empty list of the most common ones. Okay. And then we can iterate over the keys in the frequencies. Okay. So we have, well, so now we're going to find what's the best one in here. Okay, so let's go ahead, this one. Def most. Okay. So values equals, grab the values. out of here, words equals an empty list. Okay. Then, oops, I made a typo here. For, what if I iterate over a, what if I iterate over dictionary? So we can do, let's see, F equals dictionary. Okay. Let's see what happens if I do for K in F. If you just simply do for thing in dictionary, that will actually iterate over the keys. So it's actually a little shorthand for doing this. So for K in F dot keys, print K is the same as for K in F. Same thing. So when you do 4K in dictionary.keys is the same as doing a 4K in dictionary. So let's go back to our little function definition here. So we can do def most common. Okay. We can grab the values equals best equals max. And we can do, I'll just do things equals empty list or K in, so iterating over the keys, remember, if grabbing the item out of the dictionary, okay, if that's the best one, I can do things dot append. Then I did F, I think, the most common in there. Okay, so looking at my frequencies, the two most common ones in there were no and he. And both of those had a count of 5. Do you guys see what we did here? Okay. So we looped over all the values in there. We first grabbed the values. We first grabbed the best one or the highest one in there. We made a list of things. So some of you might have asked, why are we making a list when we just simply want to count? Well, because we can have multiple keys that both have the same value. Can you please go to the code? So scroll up to the code where I did the split. Sure. That was simply, I copied and pasted random text here. And then it is simply words equals text dot split. Just, yeah, it's just, split is just a method on a string. Okay. So, okay. And this is in the slides for today. So, okay. Okay. So we can do other things. We could look at how often we're looking. You know what? Maybe we could finish this up in a little bit. What if we go ahead and take a 5 minute break or so? You guys want to take a little quick 10 minute break? Yeah. Why don't we take a little 10 minute break and then you guys can play around with this little with this little counting words and then doing a little histogram. And for extra credit, since you guys know how to do a histogram, um, I'm not going to cover this, but hey, if somebody wants to plot that as a bar graph in in matplotlib, that's something you might play around with. Okay. So yeah, so let's go ahead and take a 5 minute break, okay? And we'll be back here in we'll be back here in 10 minutes. Okay. Okay. So why don't we go ahead and get started again? Okay. So we're gonna go. Okay. So we went over counting elements in a list, or counting elements, and then figuring out what the best one of those are. So now, what if we want to find not just the best one, but what if we want to grab the ordered set of what is the most frequently encountered ones? Okay. So we can write another little function to leverage our existing two functions. So what we're doing here is we're not only learning about dictionary, but we're also learning how to build up programs from simpler, more useful building blocks that we've written. So remember, we have our most common function, and we have our frequency function. So let's go ahead and assemble those into a slightly more complex one that gives you a count of how often we encounter things. Okay? So we can start with our little def, often, and then things, and then the thing. Yeah, so what we're giving it is we're giving it the things, basically the dictionary that we calculated before. And actually, I'll rename that to counts, make it a little more clear. And min. Min. The minimum frequency, and this is we want to chop this off and not enumerate everything. We only want to enumerate the minimum or the best ones that we see. So we create a little result list. Done. So while not done, okay, we're making a while loop like we introduced last time. We are going to continue running through this loop up until we encounter a stopping condition. Okay? So we can do temp equals, okay, and I believe I call that most common. Actually, things. Actually, no, I did that. Things. Okay. Most common. Okay. So remember, this is, we're calling our most common function that we defined up here. Okay, so we defined our most common one, and actually that is counts. Okay. And then remember, our most common, what is most common going to give us back? Most common is going to give us back this funny little tuple that contains the first item is going to be a list of all of the keys in there, and the second number is how often they were encountered, right? Okay, so that's going to go back to a tuple. So we're going to do if temp index 1 greater than or equal to okay. So remember, this is the second item that we're pulling out of here. This is the count. Okay. And if that's going to be greater than or equal to our minimum threshold, and 0. Okay. And then we append that. Actually, what are we? So we are going to simply take the results of our most common one and just simply stick it into our result. Okay. And now, for we are going to iterate over all of the keys in our results. So remember our best one, our most common one, it gave us back a tuple that contained the items and how often we encountered them. So what we're going to do is we want to remove those. We want to remove those from our dictionary that we got. Okay. Well, so we're actually modifying the dictionary. So we have a while loop where we continue enumerating. We will enumerate all of the items that we end up finding in. And then as we find one, we delete those, we empty out the dictionary. So essentially what our loop is we have a while loop, and then we grab items from a dictionary, we process them, and then we remove those items. So each time we go through our loop, we grab things, we process them, and then we remove them, and we keep continuing through this loop as long as we have items in this dictionary. And then we delete that one. And if else, then so we have oh, oops, I had the wrong one up. Sorry about that. Okay. All right, so let me just go over this one one more time. So we make our result. This is going to start out with an empty list, our stopping condition. Then we loop until we're not done. We grab, we call our most common function on our counts dictionary, grab the most common items in there. We look at that one. We go, if that one is better than our threshold, then we add it to our list, and then we remove those from our dictionary, and then we see, hey, so basically we check, are you better than that? And if you are, then we keep adding them and removing them, and then otherwise, we have none left. Okay? And then we just simply return result. Okay, so we've written that function. Okay. So remember our counts there. Let me scroll up a little bit here. F, most common. Okay. Let me just scroll up and make sure it looks right. So these are our words, most common. Okay. Then, just to give you a refresher, our original function looked like so. F equals frequency of words. Okay. So we did F is our things. So we can do most often F. And let's grab, how about all the ones that are better than 1? As expected, I probably have a little typo here. I made a little typo. Counts. Okay. No big deal. I simply another bug. What I do here? Okay. Did I do this correct? I'm sure I have a bug here somewhere. Ah, okay, that's why. Okay. F equals, I deleted my original result. Okay. So I did, what did I name that guy? Okay, little bug. So that I can do, and I call it most often. There we go. Okay, let's try. So what I did there is I iterated over these guys, and then I saw that these two, we encountered them 5 times. These we encountered them 4 times, 3. But if we look back at our F, did that change? Yeah, it did. You know, this is what's called a side effect, because we actually modified the dictionary itself. Okay. So we passed that in as a reference to that function. We actually modified it. So if we want to use that, we have to recalculate that. Okay. So it actually would be a little bit safer if I did it this way. A little bit safer if I run it this way. Okay. So these are all the words that occur at a frequency greater than 2, and they're sorted in the right order. So these ones we encountered as 5 times, these we encountered as 4, 3. Please encounter them twice. Okay. So that is a little bit of an example of how we go through things and how we can figure out how often we encounter them, the frequency that we encounter them. Okay, so any questions for anybody? And yeah, I mean, all this code is available on the website, so you can, if you made a typo here, you can just simply copy and paste it. Okay. So everybody good? We can go on. Let's see. Pause for questions. So why don't we get some hands of who wants to continue? I do that. Good. Okay. So we get, yeah. Okay. So we go ahead and go on. Okay. Okay. So that's the end of that slideshow. Then we can start off with another one. Okay. Open recent classes. And, okay. So I'm going to introduce the concept of what are called classes. So you guys, believe it or not, you actually have been using objects. You've just been using the built-in objects that that Python provides. And basically all the objects that you're using, somebody before went ahead and actually wrote all these class definitions, and you're using their objects. And that's really probably mostly what you'll be doing, but just give you a little idea of what exactly an object is, a little refresher. So remember, Python supports many different kinds of data. We have numbers, floats, we have numbers, floats, strings, lists, all those things. Every one of these instances is an instance of an object. And it has what's called a type. So basically all of these objects, they have some internal representation that we really don't have to be really concerned about. We don't care how they're implemented internally. The only thing that we care about is how we access them. Okay. So for example, 1, 2, 3, that is an instance of int. And we can check its type simply by doing that. Type int. Type. That's its kind, its type. Okay. You can also do, if you actually want to get